Hello, so we're going to learn one of the last sections in Chapter 2. So I know this says 3-6, but basically this is going to be Section 2-6 instead of 3-6. So it's called compound inequalities. So all the math is pretty much the same, but now it's compound inequalities. So I gave you, hopefully you guys got this handout. So let's take a look at our Venn diagram here and our inequality. So what this is looking at is, on the number line here, let's look at all the numbers that are less than 10. So again, the hollow circle, all the numbers are less than 10, and that keeps going forever. And let's look at all the numbers that are greater than 0. So here you start at 0 on the number line, and all the numbers that are greater than 0. So what this is saying is both conditions. What are all the numbers that are greater than 0 and less than 10? So that's basically everything between 0 and 10. And see how the x is in between them? So all the numbers between 0 and 10 you would graph like this. So everything greater than 0 and everything less than 10. So, you know, the numbers 1 through 9, but it includes like 9.5 and 1/2 and 1/3 and so on. So the same idea as the Venn diagram. So here's numbers less than 10, so it's everything in that circle. Those are all numbers less than 10, and there's infinite of them, you know, you can keep going. And then here is all the numbers greater than 0. So here's all the numbers greater than 0. So which ones do they have in common? So in Venn diagram, those are the ones they have in common, but again, there would be a lot more numbers than this. So this is what it would look like on a number line. So that's one type of compound inequality where you have this and this is true, where they're both true. Now we have another one where it's one or the other. So all the numbers less than 0 or all the numbers greater than 10. We're going to combine those with the word or. So are there any numbers that are less than 0 or less than 10? Well, or means it can be one or the other. So here's all the numbers less than 0. Here's all of the numbers greater than 10. And basically you just put those on the same graph. So it can be here's all the numbers less than 0 or all the numbers greater than 10. Now why do we use the or instead of the word and? Well, think about that. Are there any numbers that are less than 0 and greater than 10? Is that even possible? No, it's not possible. None of those numbers are the same. So that's why it's the word or instead of and. And that's why our Venn diagram has no overlap, because none of these numbers less than 0, which they would all be negatives, can be greater than 10. None of them are both. So we have the word or there. Okay, flipping this over. Well, this is talking about absolute value, so I'm actually going to skip that for now. Let's skip that one. Let's see. Let's just jump into our notes now. Doing some examples and talking about some of our rules. So let's get our title on there. So there are two types. Start with the first type using the word or. So if I have x is greater than 5 or x is less than 2. So let's go and draw our number line. And so this problem would go on the same number line. And you can basically treat this like graphing two separate inequalities that share a number line. So start with x is greater than 5. I circle the 5. It goes to the right. X is less than 2. I circled the 2. It goes to the left. So there it is. This graph shows that x is either less than 2 or greater than 5 because it can't be both. So basically our rule is whenever you have an or inequality, your arrows always point away. So these arrows point away from each other. So whether they're filled in or hollow, that doesn't matter, but they always point away from each other. You will never have arrows pointing the same way if you solve these correctly. That wouldn't make any sense. That would basically just be one inequality. So they should never be pointing in the same way or something like this way. So what you're going to do is solve problems like this. So let's just solve some of these. 4x is greater than 12, or 3x is less than or equal to negative 15. So you solve these just like we've been doing all chapter. You're just going to do it separately. So first solve this one. We're going to divide by 4 on both sides. And x is greater than 3. And then solve this other one by dividing by 3 on both sides. So then we get negative 5. And then graph them both on the same number line. So negative 5 is my smaller number, so give me a number smaller than that, negative 6. So now you can't skip numbers. When you do a number line, since we're graphing 2 of them, you have to count by the same increments. So negative 5, negative 4, maybe I should have counted by 2s. I'll squeeze it in there. So you can count by 2s, you can count by 5s, whatever you want, but you have to count by the same increments now. Otherwise, it won't be even and it just mathematically wouldn't be correct. Alright, so look at 1. X is greater than 3, so I circle it, greater than. X is less than or equal to negative 5, so I fill that one in, goes to the left. Now check, see, or means it points away from each other. So that's one way you can always check your work to make sure you're doing it correctly. Okay, here's number 2. Go ahead and copy that down. Pause the video to copy it. And then we're going to solve this. X plus 2, so to undo the adding 2, we subtract 2 on both sides. 5 minus 2 is 3, so that one's solved. And then we solve the next one, subtract 6 on both sides. So we get x is less than negative 4. And I draw my number line. So negative 4 is my smallest number here. And make sure you get all the way to the other number, 3, in this case. So x is greater than or equal to 3. Circle it, fill it in, goes to the left, greater than. X is less than negative 4. Circle it, I keep it open, to the left, less than, to the left. So notice or, they point away from each other. Alright, now we're going to do graphs and write inequalities from graphs. Okay, pause the video, copy down this graph. And then we're going to write the inequality. So again, you can just treat them separate. Just look at this part of the graph. This is less than 0 and it doesn't include it. So x is less than 0 without the line underneath since it's not filled in. Or, I know it's the word or because you can't have both these numbers. You can't have a number that's greater than 4 and less than 0. That's impossible. Or x is, so this is everything greater than 4, so the greater than sign. And it's filled in, so it can equal 4. So there's the inequality for that one. Here's when I see they're pointing away from each other. I know it's going to be an or situation. So looking at this one, x is less than negative 6. It's not filled in, so I don't put the line underneath. This one, x is greater than negative 2. And again, it's not filled in, so I don't put the line underneath. So there's our inequality. All right, next we're going to look at the other type of compound inequalities and inequalities. So with or, you're basically doing the same thing as before, you just do it twice. And is a little bit different. Compound, it actually does make these compound. So let's look at an example here. So we have these two, and it uses the word and. So that means it can be both of these. So I'm going to go ahead and solve these individually right now. So right here we subtract 3 from both sides. Negative 1 is less than x. And don't flip that around yet. And here we subtract 3. So this is x is greater than negative 1 and x is less than 2. So what's going to happen here, if you want to flip this around now, you can. So negative 1 and 2. Alright, so make my number line. So this is x is greater than negative 1. Circle negative 1. It's going to go over. Just leave your arrow like that for a moment. I'm going to show you why. Here x is less than or equal to 2. So we fill it in this time. and it's less than 2. Now what you do is actually connect the dots here. It has to be greater than -1, so we're not going to extend this line past that. And it has to be less than 2, so when we graph the -1, we don't extend the line past that. Basically, what we do is we connect the dots. So you graph the two numbers and you connect the dots. So and inequalities are always going to connect in the middle. And if I take this is pretty cool. Watch this. I can combine this into one inequality. I can do the -1 is greater than x, and I use that same x as this one, which is also less than or equal to 2. Check that out. This graph shows this inequality. So again, this says x is greater than -1, see it's greater than, and x is less than or equal to -2. So it's everything in between those, including the 2. So that's how your and inequalities are going to look. So now they're always going to be combined like that. And so number 5 here, we have to do some algebra. So we have to solve for x, just like before. Solve for x, get x by itself. Using the same algebra rules as before. Here, remember what we do to one side, we do to the other. So what we do to the one side, we do to the other side and the other side. There's 2 sides. So when I add 4 to get rid of that -4, guess what? You have to add 4 to this side and add 4 to this side. All right, -3 plus 4 is 1. These cancel out, leaving with just x. And 10 plus 4 is 14. So there we go. That's how we solve it. And after we solve it, now we're going to graph it. So let's count by 2's on this one. All right, so I got my number line. And now just look at this part. I circle the 1. I don't fill it in. Now look at this part. I circle the 14. I do fill it in. It has that line underneath. And think about this. If x is in the middle, your line's in the middle. You just connect it. That's kind of like the shortcut, the trick. Right here. So your x is in the middle. That means your line is in the middle. So you just connect the dots. All right, now we're going to jump into a more difficult problem, just so you're prepared for it. So just look at what's in the middle. We got to get x by itself. So it's -2 times x, then -8. So we got to get this -8. Get rid of that first by adding 8. We have to add 8 to both the right side and the left side. Add it to both sides here. -4 plus 8 is +4. These 8's cancel, leaving with -2x in the middle. And 6 plus 8 is 14. Okay, now look in the middle. It's -2 times x, so to get rid of that, we are going to divide by -2. And we do that on both the right and the left again. And yes, our rule still applies. If you divide by negative, you stop, flip the sign. So if you multiply or divide by negative, when you're solving, you stop and you flip the sign around. So these cancel. I have just x in the middle. Here's -2, -7 over here. Now you'll notice in these compound inequalities, the arrows usually go this way, and sometimes they're flipped around. All right, let's graph this. Here's my number line. So just look at the numbers. -2, circle it. Notice it's on the other side because we had to flip it. Do not fill it in. -7, circle it. I do fill it in. X is in the middle, line goes in the middle. Just connect the dots. So that's kind of the shortcut, easy way to do it. Now I'll prove it to you that it always works. So look at this. This says x is greater than or equal to -7. Greater than or equal to -7. See, it's going to the right. This says x is less than -2. -2 less than, going to the left. So it does work out for you. Okay, really fast. My video is almost out of time. Lines in the middle, x is in the middle. And so always look at this side. So right here, it's going to the left. So x is less than or equal to 5 because it's filled in. And this one is open. These always point the same direction. So that's kind of the trick. They point the same direction. And that's how you write inequalities. Sorry I had to rush through it. Good luck with everything. they always point this direction.